All right, we're looking at chapter 1.3, solving equations. Now, when it comes to solving equations, we have to do this in a way that keeps the equation balanced. Notice there's an equal sign. And for two things to be equal, they have to remain equal. So my way of remembering that is to think about the golden rule of life. Now, we all know that the golden rule of life is simply to, here we are. The golden rule of life, we know, is to treat others the way you want to be treated. Now, this implies some sort of equality in and of itself. You want equal treatment. If you're going to be nice to so-and-so, they better be nice to you too. And if they're not nice, then that kind of gets frustrating, and that's where we have issues in life, right? Well, the same thing really applies to algebra. The golden rule of algebra is that what you do to one side of an equation, you must do to the other. Now, this keeps things balanced. So if we're going to take 4 away from the left-hand side, we better take 4 away from the right-hand side. If we're going to multiply the left-hand side by 12, we better multiply the right-hand side by 12. Now, when we're solving equations, the goal is to isolate the variable on one side of the equation. Now, there are a couple of special cases, and we need to pay close attention to these. If I end up with 0 equals 0 as a solution, then there are infinitely many solutions. Infinitely many solutions. And if I end up with 0 equals some number, then there's no solution, right? It doesn't make sense that 0 equals 7 or 0 equals -1. That makes no sense whatsoever. So therefore, there are no solutions. So let's try a few out and see what we get and kind of get an idea of what I'm talking about. So here the idea is we're going to isolate the variable, which is a. We're going to isolate that on one side. And I kind of think about these like peeling an onion. So I want to start with the things that are furthest away from a, and that's going to be this plus 5. So I need to do the opposite of plus 5 in order to get the a by itself. So I'm going to subtract 5 from both sides. And I'll be left with 1/2 a equals 13. And now I have this 1/2 times a, and 1/2 times a. Well, the opposite of a is opposite of multiplication is division, so I could divide by 1/2, but that would make 13 divided by 1/2 a little bit tricky. So here, since I have a fraction, I want to multiply by its reciprocal. So I want to multiply by 2 over 1, and that will cancel my 2's and my 1's. And leave me with a on the left-hand side. And on the right-hand side, instead of multiplying by 2 over 1, since 13 times 2 seems a little bit easier to handle, I'm going to multiply by 2. And that leaves me with 26. And we put a nice little box around our answer. All right, this problem here, now look, I have variables on both sides of the equation. Now the goal, again, is to get all the variables on one side and all the numbers on the other. So I'm going to subtract the 2 from the left-hand side. So I'm going to subtract 2 from both sides. And I really like taking one little tiny step at a time. So I'm left with 5x equals 2x plus 12. And now I want to subtract my 2x because I need to get my x's on the same side. And I have 5x's minus 2x's leaves me with 3x's equals 12, and now I divide by 3. And that leaves me with x equals 4. So here for this problem, we have fractions involved. And the beautiful thing about having an equal sign is that if I multiply both sides by the LCD, then I won't have fractions anymore. I'm going to multiply the left-hand side by my LCD, my lowest common denominator, and my lowest common denominator with 4 and 3 is going to be 12. So I'm going to multiply both sides by 12. Now when I take this 12, I have to distribute to both terms. So 12 times 3x over 4. Well, 12 cancels with 4 pretty nicely. So 12 over 4 leaves me with 3. I have 3 times 3x minus, and 12 cancels with 3 really nicely, so it's going to be 4 times x. And that's equal to 10 times 12, which is 120. All right, now I can simplify one more step here. 3 times 3 is 9, so I get 9x minus 4x equals 120. And 9 minus 4 leaves me with 5 x's, and it's still equal to 120. And I can divide both sides by 5. And that's going to cancel nicely, and it leaves me with x equals, now 120 divided by 5. Well, 5 goes into 120 times, so it's going to be another 4 more, so it's going to be 24. That's my answer. And you should be able to double check with a calculator if you need to. We need to distribute before we could do anything else. So I'm going to distribute my 4 on the left hand side and distribute the 2 on the right hand side, so I'll end up with 8y plus 4 equals 2y minus 26. And now it's a matter of getting all of my y's on the left hand side or the right hand side, but I prefer the left hand side because the 8 is larger than the 2 and I like positive numbers. So I'm going to subtract 4 from both sides, minus 4, minus 4. So I get 8y equals 2y minus 30. And now I can subtract my 2y. And I'll have 6y equals negative 30. And I can divide by 6. And the 6's cancel, and negative 30 divided by 6 leaves me with a negative 5. Yeah, put a box around my answer. It looks like I need to distribute the negative 1 over here on the right hand side first before I can get all of my variables on one side and my constants on the other, or my numbers on the other side. So the left hand side I do nothing with, and I get 2x plus 7. On the right hand side I need to distribute the negative 1 to the 3 and the negative 2x. So negative 1 times 3 is negative 3, and negative 1 times negative 2x is a positive 2x. Now I want to get my numbers over there, so I subtract my 7, and I'll have 2x equals negative 10 plus 2x. And now I need to subtract my 2x from both sides. Oh no. Now I have 0 equals negative 10. Yikes. Well, that's never true, so I know for sure that this leaves me with no solution. Alright, for the last problem here, I want to make sure I handle a problem with decimals. I wanted to go through an example of decimals just so you guys see an easier way of how to handle these. Now I want to look here. I have a 3.5, 0.02, and 1.24. So my decimal goes all the way to the hundredths place. So what I'd like to do is I'm going to multiply both sides, my right hand side by 100 and my left hand side by 100. And when I do that, essentially I get to move my decimal place for every single term to the right by 2. So 30.5 times 100 is going to give me 350 minus, and 100 times 0.02 gives me 2x. And that's all equal to 124. Now I have whole numbers and they're much easier to handle. So I'm going to subtract 350 from both sides. So 350. It leaves me with negative 2x equals, now this I cannot do in my head real quick, negative 226. And now I'm going to divide by negative 2. and x equals negative 113.